Assalamu alaikum, grade 10 students. We are going to start by explaining part 2 of chapter 4, which is about vector coordinates. The objectives of this part: define a base and a reference, distinguish among three types of references of a plane, determine the coordinates of a point and the components of a vector in a coordinate plane, determine the coordinates of a vector multiplied by a real number, determine the coordinates of the sum of two vectors, and finally determine the coordinates of the midpoint of a segment and the centroid of a triangle in a coordinates plane. Materials: textbook, pens, draft papers, copybook, and calculator. Base in a plane. Definition 1. Every couple of two non-collinear vectors in a plane determine a base. Example: the following vectors I and j determine a base since they are not collinear. Remark: we write the couple ij to denote a base, so this is the notation of a base formed by two vectors, two non-collinear vectors I and j. Reference system in a plane. Definition 2. Let ij be a base in a plane P. Let OI and j be 3 points in this plane such that vector OI equal vector I and vector OJ equal j. So the triple OIJ or OOIOJ is called a reference or a system. So the triplet OIJ form a reference. This is the notation of a reference system. Particular cases of reference systems. Let ij be a base in a plane P. The table below represents the different forms of reference systems. The first one is normal system, in which the two vectors I and j are equal in norms. Their norms must be equal. While in orthogonal system, the norms are different, but the two vectors must be orthogonal. The third one is orthonormal system, in which the two vectors are equal in norms and they are also orthogonal. Here, I orthogonal to j and norm of I must be equal to norm of j. Definition 3. Let ij be a base in a plane P. Any vector u in a system ij is written in terms of I and j. In other words, a vector u is equal to xi plus yj, where x and y are real numbers. Remark: the vectors xi and yj are called the vector components of u. X and y are called the scalar components of u. X and y are called the scalar components. The first component, x, is the abscissa of u, and the second component y is the ordinate of u. The coordinates of u are represented by the pair xy, and we write u of coordinates xy. Example 2. In a system ij, determine the coordinates of two vectors u and v. Here, since u equal to I plus 3j, so the abscissa is 2 and the ordinate is 3. Similarly for vector v, the abscissa is minus 3 and the ordinate is 1. Application 1. Please stop the video a few minutes to solve this application. Properties. In a system OIJ, consider the two vectors u of coordinates xy and v of coordinates x prime y prime. If u x, y, and v x prime y prime are equal, then the abscissas are equal, x equal x prime, and the ordinates are equal, y equal y prime. 2. The coordinates of vector k times u are kx, ky, where k is a real number. 3. The coordinates of vector u plus v are x plus x prime, y plus y prime. We add the abscissas and we add the ordinates. 4. The coordinates of vector u minus v are, similarly here we subtract x minus x prime and y minus y prime. Example 3. In a system Ij given the two vectors u 2, 3 and v minus 3, 1, determine the coordinates of vector w in each case. Part 1, w equal to u. So here we have to multiply 2 by these coordinates. In part 2, we have to multiply minus 3 by the coordinates of vector v. And in part 3, we have to add the abscissas of u and v and the ordinates of u and v. Application 2. Please stop the video a few minutes to solve. Coordinates of a point. Definition 4. Consider a point M in system Oj. The vector OM is written in terms of I and j. You can review definition 3. In other words, OM equal xi plus yj, where x and y are unique real numbers. Remark: the first component x is the abscissa of OM, and the second component y is the ordinate of OM. The first component x is also called the abscissa of point M, since OM and M having same abscissa because the coordinates of O are 0, 0. And the second component y is called the ordinate of M. The coordinates of M are represented by the pair xy, and we can write M of coordinates xy. Example 4. In a system Ij, determine the coordinates of M and N such that OM equal 5i minus j and ON equal minus I. Here we have OM of coordinates 5 and minus 1, and since O having coordinates 0, 0, so M having same coordinates 5 and minus 1. Similarly, here we have ON equal minus I or minus I plus 0j, so minus 1 and 0. Note that the coordinates of origin O are always 0, 0. Application 3. Please stop the video a few minutes to solve this application. Coordinates of vector AB. Definition 5. Let A and B be two given points in a reference system Oj. You know that AB vector equal AO vector plus OB vector, then AB equal OB minus OA, then AB equal XBI plus YBJ, since OB vector is equal to XBI plus YBJ, minus OA vector, which is equal to XAI plus YAJ. Then AB equal XB minus XA between parentheses into I as a common factor, plus YB minus YA into J as a common factor. So the components of vector AB are XB minus XA and YB minus YA. Example 5. Given the points A 1 minus 2 and B minus 3 1, determine the coordinates of vector AB. By applying the formula, we get AB XAB YAB means XB minus XA, which is minus 4, and YB minus YA, which is 3. So AB having coordinates minus 4 and 3. Application 4. Please stop the video a few minutes to solve this application. coordinates of particular points. Formulas. In a system OIJ given the points A, B, and C. 1. Let I be the midpoint of AB. Then the coordinates of I are xi equal xa plus xb over 2 and ya equal ya plus yb over 2. Let G be the centroid of triangle ABC. Then the coordinates of G are xg equal xa plus xb plus xc over 3 and yg equal ya plus yb plus yc over 3. Example 6. In a system OIJ given the points A, B, and C, determine the coordinates of I, the midpoint of AB. Solution. xi equal xa plus xb over 2, which is equal to 3, and similarly yi equal to, so I 3, 2. Part 2, determine the coordinates of G, the centroid. Also by applying this formula, we get that xg equal 2 plus 4 plus 0 over 3 equal 2 and yg equal minus 1. So G of coordinates 2 and minus 1. Application 5. Please stop the video a few minutes to solve this application. Summary for this part. Coming next. I hope you understood this part and please study well.